Hello students, welcome to AS Online. In this video, I am going to solve questions that were asked in GATE DA 2024 paper from Engineering Mathematics. So, if you look at the weightage, nearly 35 to 40 marks were asked from Engineering Mathematics. So, here is the individual subject or individual topic weightage. From probability and statistics, we have got 4 1-mark questions, 6 2-mark questions, and we have few more questions which are related to probability and statistics which are not mentioned here. So, nearly 20 marks, here I pointed 16 marks, but nearly 20 marks were asked from probability and statistics part. If you look at linear algebra section, 2 1-mark questions, 4 2-mark questions, total 10 marks from linear algebra. So, next calculus and optimization. So, there are 2 1-mark questions and 3 2-mark questions. So, total 8 marks from this. So, now you are going to solve questions that were asked from engineering mathematics in GATE DA 2024 paper. So, here is the first question. The probability of a boy or a girl being born is 1 by 2. For a family having only 3 children, what is the probability of having 2 girls and 1 boy? So, that is the question. So, after reading this question, so what do you feel? So, do you feel like this is related to binomial random variable? So, here the experiment has got only 2 possible outcomes, namely a boy or a girl. So, they also mentioned that the probability of boy is equal to the probability of girl, so which is obviously 1 by 2. So, the first thing is there are only 2 possibilities, namely boy and a girl. So, the moment you see the experiment having only 2 possibilities, so you need to link this with a binomial random variable. So, let us write like this: let x represent number of girls. So, they are talking about number of, what is the probability of having 2 girls and 1 boy? It is okay, we will talk about number of girls. Let x represent number of girls in a family. So, if you carefully observe, so the total, he says for a family having only 3 children. So, I can set the value of n as 3 and probability of a girl. So, you can set p value as 1 by 2. So, you can set p value as 1 by 2 and then you can ask what is the probability of having 2 girls. So, automatically when you say when you set n as 3 and you ask a question that the probability of x equal to 2, so it indirectly means, so you are finding the probability of having 2 girls and 1 boy. So, let us use the probability mass function of a binomial random variable. So, what is the probability mass function of a binomial random variable? The probability of capital X taking this particular value small x is NCX p power x 1 minus p whole power n minus x. So, this is the probability mass function, you can directly substitute. So, it is 3C2, it is 1 by 2 whole power 2 and then 1 by 2 whole power 3 minus 2. 3C2 we all know it is 3 and then you have this 1 by 2 whole power 2 which is 1 by 4 and then you have 1 by 2 whole power 1 which is 1 by 2. So, this gives you 1 by 8. So, finally, the answer is 3 by 8. This is one way of solving the question. We have another way of solving the question, let me tell you that way. So, he says the probability of a boy or a girl being born is 1 by 2, so equally likely, and a family has got 3 children. So, have a look at what is the sample space. So, let us look at what is the sample space, an alternate way of solving. So, it can be something like this, it can be girl, 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 it can be girl, girl, boy, it can be something like this. So, something like 0, 0, 0, 0, 0, 1 or something, you all know how to write these things. So, just let me fill this. So, this is like 0, 0, 1, 0, 1, 0, something like this and then like this and then it can be like this. And finally, it is like this. So, each outcome has got 2 possibilities. So, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes, yes. So each outcome has 2 possibilities, and then there are 3 children. So that is why you have got 2 power 3, which is 8 outcomes. Now in this, what he says, what is the probability of having 2 girls and 1 boy? Have a look at those sample points, let us look at those sample points where you have exactly 2 girls. So which is that? So let me use another color to highlight that. So this is the one, this is the one where exactly you have 2 girls. So do we have anything else? Yes, this is another case where you have exactly 2 girls. So how many sample points are there? There are 3 favorable sample points among the total 8, hence the answer is 3 by 8. Such a simple problem this is. So the moment you see the statement that the probability of a boy or a girl being born is 1 by 2 for a family having only 3 children, you have to link this to binomial random variable, or you can also have a look at this, and then through that also the answer is 3 by 8. This was asked in aptitude section, but this is also part of our probability and statistics. That is the reason why I am explaining this. The next question is, consider the following statements. The mean and the variance of a Poisson random variable are equal, and then for a standard normal random variable, the mean is 0 and the variance is 1. Which one of the following options is correct? So the question is about Poisson and standard normal random variable. So let us quickly revise those distributions and their properties. If you look at Poisson random variable, so what is the probability mass function? The probability mass function is something like this. It is e power minus lambda, lambda power x by x factorial, where x takes values like 0, 1, 2 and so on. If you try to find its mean, because in our classes we give the mean and the variance directly. So when you try to find this, so the definition says it is summation over all x, it is x into the probability of x. So when you substitute then do the simplification, so after many steps you will see one simple result, and that is lambda. The mean of a Poisson random variable is lambda. Same way, if you find the second moment, that is e of x square, which is like this summation over all x, it is x square into the probability of x. If you try to find this, you get some result. Let us say you do not remember that, that is also fine, but with this you have to find the variance. The variance of x is e of x square minus e of x whole square. So when you substitute these two informations here, you get another simple result, that the variance of Poisson random variable is again lambda. So we usually do these calculations in the classes, or sometimes we do not do. We say, look, this is the Poisson distribution, this is the mass function, this is the mean, this is the variance. So finally the question is about they are comparing, or they are saying that the mean and the variance are same. Yes, they are same. And you can also figure out what is a second moment. So for example, if the variance is lambda and this is this, then the variance or the second moment is something like this, lambda square plus lambda. So this needs lot of calculation. Usually in our classes we just give these relations to the students. So this is the first statement is true, yes. Have a look at the second statement. So what is the second statement about? The second statement is about, I think, the normal distribution, standard normal distribution. So he says for a standard normal random variable the mean is 0 and the variance is 1, yes. So the standard normal random variable is denoted with z, its probability density function is 1 by root 2 pi e power minus z square by 2, so where z takes values from minus infinity to infinity. When you try to find the mean of this random variable, which is obviously a very difficult calculation, it turns out to be 0. And when you try to find the variance of a standard normal random variable is always 1. So I just wanted to revise the density function, the mean and the variance. Yes, both the statements are true. Do we have such options where both the statements are true? Yes. So option A is right for this question. 3 fair coins are tossed independently. T is the event that 2 or more tosses result in heads. He is defining certain event called T, and then he defines S is the event that 2 or more tosses result in tails. What is the probability of the event T intersection S? So so simple. Why don't you figure out what is the sample space, look at what are the points in T, what are the points in S, and see what are their intersection, or what are the points in the intersection, and then comment on their probability. So he says 3 fair coins are tossed independently. If you toss one fair coin, you get 2 possible outcomes. If you toss 2 fair coins, you get 2 power 2, that is 4 possible outcomes. If you toss 3 fair coins, you get 2 power 3, which is 2 power 3, which is 8 possible outcomes. What are those 8 possible outcomes? So let me try to show them. So have a look at the sample space. These are very simple problems. Sample space contains points like this: tail, 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 this is one point, tail, tail, head, tail, head, tail, tail, head, head, and then you got few more points like head, tail, tail, head, tail, head, 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 tail, and then finally all heads. So there are 8 points in our sample space. He talks about events called T and S. Let us figure out what are the points in those sets. So what is T? He says T is an event that 2 or more tosses results in heads. 2 or more tosses results in heads. Let us see what are the points in T. 2 or more tosses results in heads. So look, there are 2 heads here, so collect that, T, H, H. Look at this, H, T, H. Look at this, H, H, T, and then look at this. So these are the points that will go to T. Similarly, what is S? They defined another event called S. It's the event that 2 or more tosses result in tails. Pick those points in which you have got 2 or more than 2 tails. Okay, so obviously this fits here, so all tails, and then tail, tail, head, tail, head, tail, and then yes, head, tail, tail. Do we have anything else? No. So these are the points in S. Now have a look at their intersection. Do we have any points in common? Do we have any points? Look, there are 2 or more than 2 heads here, and here there are 2 or more than 2 tails here. So obviously there are no common elements. So the conclusion is that T intersection S will be a empty set. Now if this is an empty set, obviously what's the probability of that empty set? The probability of that empty set is obviously 0. Such a simple problem was asked in our exam. So let's go to the next problem. Yeah, this is one of the fantastic problems that were asked in GATE DA paper. So maybe other subject, maybe artificial intelligence or machine learning faculty might also claim this question, because they might also have similar concepts in their syllabus. Let us read this. Consider 5 random variables u, v, w, x and y whose joint distribution satisfies this condition. P of u, v, w, x, y equal to P of u into P of v into P of w given u, v into P of x given w into P of y given w. Which one of the following statements is false? So we are supposed to identify the false statements. Y is conditionally independent of v given w. X is conditionally independent of u given w. U and v are conditionally independent given w. Y and x are conditionally independent given w. So how do you solve this? You need certain basics to solve this question. So let us try to see what are those basics. Let me talk like this. Suppose if A and B are independent, let us say A and B are independent, then we have this standard condition. If A and B are independent, then the probability of A intersection B is simply probability of A into probability of B. I hope everyone knows this. If A and B are independent events, then the probability of their intersection is equal to product of individual probabilities. We need exactly this point in solving the question. Next, let us take A, B, C to be events. Okay. So suppose, let us say like this, if A, B and C are events such that, suppose let us say if A, B, C are events such that, have a look at this, P of A intersection B given C satisfies this condition, that is probability of A given C into the probability of B given C. Okay, have a look at this statement, try to observe this very carefully. You need very good basics to understand the entire question. First, I started that if A and B are independent, then we know a condition that P of A intersection B is equal to P of A into P of B. Or you can also say if this condition is met, that is P of A intersection B equal to P of A into P of B, then you can claim that A and B are independent events. Same way or similar concepts, suppose A, B, C are events which satisfy this condition, that is P of A intersection B given C is equal to P of A given C into P of B given C, then we can claim that A and B are independent, or we can claim that A and B are conditionally independent given C. So, let me write, if ABC events are such that this is equal to this, then have a look at this powerful statement, then A and B are, this is a very important idea, conditionally independent, they are conditionally independent given C, okay, given C. This proper or this point will help you to identify the correct answer for the question. So, I see that there is a term like this, have a look at this, P of x given W into probability of y given W. Can you see a term like this in the given equation? Yes. Now, which indicates that x and y, just like the way you wrote A and B are conditionally independent given C, in the same way you can claim that x and y are conditionally independent given W. So, because of this term indicates that x and y are conditionally independent given W. So, yes, this is a true statement, but what is our duty? Our duty is to identify a false statement. So, this is a true statement. What about U and V are conditionally independent given W? So, what you need to check is, do we have any terms like this? U given W into the probability of V given W in our given equation. Do we have such options? We have something like P of U into P of V, but we do not have P of U given W into P of V given W. So, there is no such information to claim that U and V are conditionally independent given W. So, obviously this is a false statement, students, or this need not be true, this is a false statement. Which one? Option C, and this is going to be the answer for our question, because the question talks about identifying the false statement and we have done that. Now, some of you might also be interested to know about A and B, okay. So, let us talk about A and B. Now, before we talk about A and B, let me again come back. Suppose, maybe I will minimize this. Even analyzing A and B is so simple, it is not a big task. I will just help you with that. Let us talk about A and B. Suppose, let us say again, if A and B are independent, then let us see what happens. Then we have studied that the probability of A intersection B is simply P of A into P of B. Not only this, if they are independent, then they also satisfy this. P of A given B will be exactly P of A, students. P of A given B will be P of A. I hope you would have studied this in your basics. The same way you can also write P of B given A to be what? P of B. So, this is the consequence of A and B being independent. So, now why am I stressing on this? Why am I stressing on this? You will understand in some time. So, let us put it here. Now, let us read option A and B. Let us read option A and B. Y is conditionally independent of V given W. Y is conditionally independent of V given W. That means you, for example, let me write like this. Y given V comma W is now same as the probability of Y given W. You will not have terms like Y given V comma W because Y is conditionally independent of V. See here, if A and B are independent, now what is the conditional probability P of A given B? It is directly P of A. Same way, since it is conditionally independent of V, you do not have V here, okay. Now clearly in the options I have P of Y given W, I have Y given W, nowhere we have V comma W. So from this we can claim that yes, Y is conditionally independent of V given W. Similarly, you can write same argument is applied on the next option, X is conditionally independent of U given W. So, U comma W can be written as probability of X given W. Now you can see a term like this, you do not see this because U comma W, since X is conditionally independent of U, you do not have U here. So do you see X given W term in our expression? Yes, X given W. So yes, this is a true statement, students. This is also a true statement, and option D is also a true statement, but option C need not be a true statement. So some of you I think would be confused here, sir, why are you saying this? See here, if it was dependent, you will definitely have V comma W here. Since we do not have V here, we can claim that Y is conditionally independent of V given W. So finally, let me just revise because this is one of the fantastic questions. Let me quickly revise what we have done so far. So there is a problem given to us like this and we need to identify which is the false statement. To solve this question, you need to have a crystal clear idea of what is conditional probability. You need to know what are independent events. Then you will understand this. If you do not know the definition, if you know only the formula of conditional probability, if you know only the formula of independent events, you will never be able to understand the solution. So he says that some equation is given. From this we need to understand or we need to answer which is the false statement. So the basic idea is if probability of the intersection is equal to product of individual probabilities, they are independent. Same way, just like the way you said, suppose if you have events which are satisfying this, P of A intersection B given C is P of A given C into P of B given C, then you can claim that A and B are conditionally independent of, they are conditionally independent given C. This is what we can claim. And in the options I see X given W, probability of X given W into probability of Y given W. So you try to compare this, A given C, B given C, their product is there. So here also same, that means X and Y are conditionally independent given W. But we do not have terms like U given W, the probability of U given W into probability of V given W. So you can't apply the same result to U and V. That is why we eliminated or we said option C is false and we got our answer. Similarly, we applied the basic conditional probability definitions on A and B and we figured out yes, they are true statements. So this is one of the fantastic problems, students. Let us look at the next question. Let the minimum, maximum, mean and the standard deviation values for the attribute income of data scientist be rupees 46,000 and some values are given, okay, respectively. The z-score normalized income value of this is closest to which one of the following options. So it is about the normalized z value. So how do you find the normalized z value? It is so simple, the normalized z value of x. So let me write like this. the normalized z value of x is given by x minus mu divided by sigma. So, what is that observation they gave? They gave this observation 106 000 minus what is the mean? So, mean, they gave the minimum, maximum, mean. So, minimum, maximum, mean is this 96 000 and then whole divided by the standard deviation. They gave the standard deviation, yes, they gave the standard deviation which is 2100. If you use your calculator, you will get the answer and it turns out to be, this is closest to this 0.476. You can use your calculators to get the answer. This was another simple question. Let us look at this. This question was also mentioned in the sample question paper, a similar question. So, a sample average of 50 data points is 40. The updated sample average after including a new data point taking the value 142 is dash. Okay, so simple problem. So, what they say is they have got 50 points it seems, then the average turned out to be 40. Okay. So, how do you find that? You find like this x1 plus x2 plus up to what? How many observations are there? 50. So, x50 by 50, sum of the observations by number of observations turned out to be how much? 40. From this, can you figure out what is x1 plus x2 plus so on plus x50? It is 40 into 50, I think it is 2000, you can check it with your calculator. And then he says after this they added a new observation. So far we have got 50 observations, but now they added a new observation. So the number of observations will increase by 1. So now the total number of observations are 51. They want the average of that. And what is that new point, student? After including a new data point taking the value of 144 is. So the new mean or the updated mean. So have a look at this. Updated mean is x1 plus x2 plus so on plus x50 plus x51. x51 is provided as 142 and then whole divided by the total number of observations is 51. So now what is x1 plus x2 plus so on x50 from this? It is 2000 and then you have this 142 whole divided by 51. So it is 2142 by 51. I think this ratio might give you 42, I am not sure, please verify this, you can use your calculators. So this is how you find it, okay. A fair 6-sided die with faces numbered 1, 2, 3, 4, 5, 6 is repeatedly thrown independently. What is the expected number of times the die is thrown until 2 consecutive throws of even numbers are seen? So various options are given, and if you carefully observe this pattern, or I can say almost exactly the same question also appeared in the previous GATE exam. Almost all the data is same except for a die. Here they talk about a die, in the previous GATE exam they talk about a coin, okay. So all answer is also the same, that is the interesting point. Why the answer is the same, I will tell you as we progress. A fair 6-sided die, okay. So there is a die, fair die, it is rolled it seems. What is the expected number, that is the average number of tosses needed to get 2 consecutive even numbers? 2 consecutive even numbers. So how do you solve this? Not that easy. So if you have solved the previous GATE question, then you would have just ticked the answer and gone to the next question. So let us talk about the sample space. The sample space contains the 6 points 1, 2, 3, 4, 5, 6. So what is the probability of even number? Here in this particular case, the probability of getting a even number is exactly same as probability of getting a odd number which is equal to 3 by 6 which is 1 by 2. Probability of even and the probability of odd are equally likely here, because from 1 to 6 if you see 1, 3, 5 are the odd numbers, there are 3 odd numbers, 2, 4, 6 there are 3 even numbers. So they are equally likely. In the previous gate question also, instead of a die they were talking about a coin toss where the probability of head and the probability of tail are again same, they are also equally likely events. Now what he wants is, so until you get two consecutive even numbers, the coins are, until you get two consecutive even numbers, the die is continuously thrown. So what is the average number of throws? What is the average number of throws to get two consecutive even numbers? That is the question. So in the previous gate also the question was, what is the average number of throws or average number of tosses to get two consecutive heads? So almost the same pattern, the answer is also the same. So how do you solve this? So let us assume that let x be the average or the expected, let x represent the expected number of, let x represent whatever it is, let x be the expected number of times. So I am just copying this, times the die is thrown until two consecutive throws of even numbers are seen. Okay. So finally we are interested to get what? We are interested to get the value of x. So because we said x represents the expected number of tosses to get two consecutive even numbers. Okay. So we are obviously interested to get the value of x. So what's going to happen? This is completely a new problem, students. So see how I am going to solve. So have a look at case 1. If the first throw, is, let us say, odd number. So you started this experiment and you tossed it or you have thrown it, but you have seen a odd number. So that means what is our intention? Our intention is to get two consecutive even numbers, but the first throw resulted in an odd number. That means you have wasted first throw or you have wasted one throw. So if the first throw is odd, that means, so odd, so we have wasted, so we have wasted one throw, and the probability of this outcome, and of this event, which event? The probability of getting a odd number in the first toss. So what's the probability of this event? The probability of this event is 1 by 2, because we clearly wrote the probability of getting an odd number is 1 by 2. Okay. So if the first throw is odd, so we have wasted one throw and the probability of this event is 1 by 2, and we need, so since we have already wasted, so again it takes x more number of throws to get two consecutive even numbers. So this implies that, so we need, and we need, this is very very important, we need x plus 1 throws, x plus 1 throws. Okay, so throws, so s is missing there, you adjust it, and we need x plus 1 throws to get two consecutive, okay, two consecutive even numbers. Okay, even numbers. This is the first case, students. So it's a very lengthy question. Let me explain it one by one. What is case 2? Let us see case 2. Suppose if the first toss even and the second toss, I think instead of toss, yeah, toss is also fine, or throw, whatever is convenient you write. So let me just write toss here. If the first toss is even, okay, if the first toss is even and the second toss is odd, so you have a die, so you have thrown it, you have tossed it, so the first outcome was even, the second outcome was odd. So what happened was, the main objective of this problem is to get two consecutive even numbers. So you started that process, but first you got even and then odd, that means you have again wasted two more tosses, but that because the idea is to get two consecutive even numbers, something like even and even, but here you got even, odd, so you have wasted two tosses, again you need x more, or average, you need x average number of tosses to get two consecutive even numbers. So if the first toss is even and the second toss is odd, this implies that, so we have wasted, so we have wasted two tosses or two throws, whatever is convenient you write. So we wasted two tosses and the probability of this event, which event? The event where the first toss is even and the second toss is odd. The probability of this event is how much? It is 1 by 2 for the even number and again 1 by 2 for the second toss which is odd. So 1 by 2 into 1 by 2 is 1 by 4. The probability of this outcome, the probability of this event is 1 by 4, and we need, this is very important, and we need, since we wasted two tosses, we need x plus 2 more tosses, or we need x plus 2 tosses now to get two consecutive even numbers, and we need x plus 2 tosses to get two consecutive even numbers. Okay, this is second case, students. Now there is another case, so let me elaborate this one by one. This is case 2. Let's put this here. So what is case 3? Let's talk about case 3, students. So in case 1, what we have done is, we said first throw is odd, okay, and here we said first toss or the first throw is even and the second throw is odd. So it can be like this as well. If the first throw is even and the second throw is even, what's happening here? So first throw is even and the second throw is also even, that means our objective is achieved. This is what we want. So you can stop, we can stop here. So and the probability of this event, and the probability of this event is 1 by 2 into 1 by 2, which is 1 by 4, and how many throws we need, or how many throws we needed here is 2 throws. First throw even, second throw is also even. Now these are the 3 cases. You might get few more doubts, sir, there might be one more case, like you might be thinking something like this: even is covered now, even odd is covered in the second case, and just odd is covered here. Sir, why not odd even, sir? Why not odd, sir? Sir, this odd even, sir, and odd, sir, these are already covered in the first case, sir. Because what we said is, if the first toss is odd, so what's happening? We have already wasted one toss. So the next, it can be even or it can be odd. So that's why we said if the first toss is odd, we already wasted one toss. We need on an average x more tosses to get the two consecutive even numbers. Those two cases, which two cases? Even odd, odd, sorry. Odd even, odd are already covered in case 1. That's the beauty here. If the first toss is odd, we have already wasted one toss. So we need x more, or on an average we need x tosses to get 2 consecutive even numbers. That is why the total tosses are x plus 1. Those 2 cases of odd even, odd odd are already part of case 1, and the remaining cases of even odd is covered here and even is covered here. So, we have done with this. Now, what is the average number of tosses? We have not figured out the answer, we just wrote some cases. What would be the answer? So, we will now analyze all the 3 cases. From those 3 cases we get the answer. I will tell you how. So, we assume that the average number of tosses is x. You can now equate this x to, so in the first case what is happening is, if the first throw is odd, we need x plus 1 throws, and the probability of this event is 1 by 2. So, you can multiply 1 by 2 like this. You can multiply 1 by 2 into x plus 1 plus, what is the second case? If the first toss is even and the second toss is odd, so you need x plus 2 tosses. So, x plus 2 tosses has to be multiplied with the probability of that event, which is 1 by 4 plus. And the third case, in the third case where you get first throw even, second throw is also even, so the probability of that event is 1 by 4 multiplied with how many tosses were needed? 2. If you solve this equation, you will definitely get the value of x. So, let me solve this equation, x equal to, so the LCM is 4. So, here you will have 2x plus 2 plus here you will have x plus 2 and then here you will have 2. So, this 4x goes here, so 4 goes here and becomes 4x. This is how much? This is 3x and this is plus 6. If this goes here, 4x minus 3x is x, x equal to 6. So, we got the value of x. Exactly the same question appeared in the previous GATE exam and the answer is also 6. Those who have solved would have definitely put the answer as 6 without any solving. So, what was that question? Instead of a fair die, they talked about a coin and they wanted 2 consecutive heads. Why the answer is same? The answer is same because the probability of getting a head, the probability of getting a tail is again 1 by 2. So, that is why the answer is again 6. I hope you would have understood this. You would have struck again at this point, sir, only first toss is odd, why not odd even, odd odd? Because if the first toss is odd, that is not favorable to us. We need again x more tosses to get 2 consecutive even numbers. So, now why you might feel like, why did you equate this? Here this represents the expected number of tosses and the other side, the right side also represents the average number of tosses. So, that is why I have equated. So, through this equation solving I got the value of x. So, let us see the next question. Here they say that x is a random variable uniformly distributed in the interval 1 to 3. Y is also a random variable which is uniformly distributed in the interval 2 to 4. If x and y are independent of each other, then the probability of x greater than or equal to y. This pattern has repeated many number of times so far. So, how do you solve this in a simple way? Okay, how do you solve this? Let us say that x is in the interval 1 to 3, right? So, let us mark this is 1, let us say this is 2, let us say this is 3. Let us say this is the random variable x which is taking values from 1 to 3. What about y? Y takes values from 2 to 4. So, maybe here is 2, let us say this is 3 and somewhere here is 4. Now, what could be the sample space? So, sample space is obviously a rectangular grid, okay, a rectangular grid where x will be from 1 to 3 and y will be from 2 to 4. So, let us say this is 1. So, clearly a rectangular grid, let me use another color, will this be okay? Of course, it should be okay because x is taking values from 1 to 3 as specified here and y is taking values from 2 to 4 as specified here. Now, they talk about some event, the probability of x greater than or equal to y. So, already this kind of problems have like appeared. They talk about probability of x greater than or equal to y, which is same as y less than or equal to x. X greater than or equal to y same as y less than or equal to x. So, when you are dealing with such questions, first look at what could be y equal to x. What could be y equal to x? Y equal to x represents a straight line passing through origin. Okay, y equal to x is a straight line passing through origin. Why don't you draw that? Let me use another color. Let us draw y equal to x graph. So since y is x, you can take points like 2 comma 2. Okay, this is 2 comma 2. Let's say this is the point 3 comma 3. So this is how it looks. A rough graph I have drawn. This is how it looks. What is this? This line represents y equal to x. But what is that region we want? We want y less than or equal to x. Y less than or equal to x. So if you draw a straight line, the region above this is y greater than x. The region below this is obviously y less than x. So let me shade with this color. Have a look at this. This shaded part is going to represent, this is the region where y is less than or equal to x. So now what's the answer? The answer is so simple. If you want the probability of x greater than or equal to y, then this is same as the probability of y less than or equal to x. So it's like, what is area of this shaded part and what is the total area? So let me look at the shaded part area. So the shaded part area is half base into height. So this base is 1, you can see through a simple figure the base is 1, and through this figure we can see that the height is also 1. The height is 1. Now this is the area of the triangle. Next, divided by, now the sample space is a rectangle. So what is area of a rectangle? Length into breadth. So how much is this? This is 2. How much is this? This is also 2. So the answer would be like 2 into 2 into 2 is 8. So the answer is 1 by 8. This kind of questions have already appeared in our previous GATE examinations. This is the simplest way to solve the question. So let x represent, or let x be a random variable exponentially distributed with parameter lambda greater than 0. The probability density function of x is given by f of x is lambda e power minus lambda x for x greater than or equal to 0, and it is 0 otherwise. We all know that it is exponential, the probability density function of a exponential random variable. And they also gave 5 times expectation of x is variance of x, where e of x and the variance of x indicate the expectation and the variance of x. The value of lambda is dash. So given this condition, they want the value of lambda. So you are supposed to know what is the mean, what is the variance of a exponential random variable. So have a look at this, the mean, because in the classes we already teach you all the properties of a exponential random variable or various distributions. The mean of exponential random variable is 1 by lambda, and the variance of exponential random variable is 1 by lambda square. Now they gave a condition that 5 expectation of x is variance of x. You can now substitute these values and you can solve for lambda. Something like this, 5 into 1 by lambda is 1 by lambda square. So lambdas cancel, 5 is 1 by lambda. This implies the value of lambda. The value of lambda is 1 by 5, which is 0.2. So this is a very simple question. So let's go to the next one. He says, consider 2 events t and s. Let t bar denote the complement of the event t. The probability associated with different events are given as follows. The probability of t complement is 0.6. The probability of s given t is 0.3. The probability of s given t complement is 0.6. Then what's the value of the probability of t given s? Again, this pattern has appeared many number of times in the examination. If you would have watched our videos, so you could have easily solved. So what is the given data? They gave some given data, the probability of t complement is 0.6, okay. So what is asked? The probability of t given s, this is asked. Now according to the conditional probability definition, this is given by t intersection s by p of s. So what are the things that you don't know? I don't know probability of s, I do not know the probability of t intersection s as well. So, we do not know the numerator, we do not know the denominator. So, through the given data you need to extract these two values and then find the answer. So, let us put this aside for a while. So, the idea is to get the numerator as well as denominator. So, let us see how to extract those information. They gave something like this, the probability of S given t. How much is this? This is 0.3. Now, according to the conditional probability, this particular probability can be written as S intersection t by the probability of t. So, this has to be how much? This has to be 0.3. Now, since the probability of t complement is 0.6, what would be the probability of t? So, the probability of S intersection t divided by, it would be 1 minus 0.6, 1 minus 0.6 is 0.4. So, I will just write like this, the probability of t is 1 minus the probability of t complement, 1 minus 0.6 is 0.4, you can utilize that here. So, how much is the intersection now? The probability of S intersection t is 0.3 into 0.4, I think it is 0.12. Okay. So, we got the numerator. The next idea is to get P of S. If you can get that, we have solved this question. Let us use another information. So, what is another information? P of S given T complement. How much is this? 0.6. Maybe this might give us some information. So, according to the conditional probability, this is S intersection T complement divided by the probability of T complement, which is equal to what? 0.6. What is the numerator probability? So, maybe some Venn diagram let us draw. Let us say this is S, let us say this is T. So, what could be the T complement, students? What is T complement? So, will this be T complement? Let us check it. So, whatever I shaded in blue is T complement. What we need is S intersection T complement. So, what could be S intersection T complement? You can see S here, you can see the blue lines as T complement, and their intersection is obviously this part. So, this yellow part is S intersection T complement. If you want the probability of that, then the idea is so simple. From this portion, which is P of S, you subtract this portion. Okay. So, that is the idea. So, the numerator is nothing but P of S minus P of this portion is S intersection T by P of T complement is 0.6 and this is also equal to 0.6. What we need is P of S, we already know S intersection T probability. So, P of S minus 0.12 is 0.6 into 0.6 is 0.36. Finally, we have P of S which is 0.48. So, do you know the denominator? Yes, we know. How much is that? 0.48. Do you know the numerator? Yes, which is 0.12. So, cancels, 12 ones are 12, 4s are 1 by 4, 1 by 4 is 0.25. So, the answer for this question is 0.25. Students, let us look at this question where marks to all was given. Why marks to all was given? So, what is the issue behind this? Let us try to analyze. Consider a joint probability density function of two random variables x and y. So, the joint PDF is given as 2xy where x is from 0 to 2 and y like 0 less than y less than x, and for all other values the PDF, the joint PDF is 0. So, what is a conditional mean of y for given x equal to 1.5? This was asked. Marks to all was given y. So, if this was a valid probability density function, students, so if you try to do the double integration this way, so have a look at this. If you perform or if you try to find, suppose if this represents some surface, if you try to find the volume beneath that surface, so that volume must be 1. So, if you are new to this, then you just check this. Just like we say area under any probability density function must be 1, same way this should also be dx dy, this should also be 1. So, over whatever limits they gave. Okay, so let us see whether this will give us 1 or not. So this computer science students or the students who are preparing for the data science, so for them this double integration is a little new. So you need to follow a proper order. So let's write like this: x is clearly from 0 to 2, and what is y? Y is from 0 to x. What is f of x comma y? It is 2xy. So the first integration is dy, I mean it is with respect to dy, and then it is with respect to dx. So try to quickly find this. So while performing the integration with respect to y, so some of you might be new to this kind of integration. All other non-CS students, they are aware of performing this double integration, but CS students are new. So while integrating with respect to y, you can treat x as constant. So 2x is a constant, and then it is y square by 2. So if you substitute the limits, so let's see what happens. There is one more integration where x is from 0 to 2. So how much is this? When you put this, it is x square by 2. So this 2 cancels. So what is left is x from 0 to 2. When you put this, it is x square, and then the lower limit is gone. X into x square is x cube. So try to find this. Integration of x cube is x power 4 by 4, and the limits are 0 to 2. So when you substitute the upper limit, it is 2 power 4 by 4. So 2 power 4 is 16, 16 by 4 is 4. So like I said, this double integration should give us 1, but the double integration is giving you 4, meaning by this is not a valid probability density function. This is not a valid probability density function. Hence, so whatever you try to do may not give you proper results. That's the reason why they gave marks to all. But initially they gave a key. Okay, initially they gave 1. So except for this, remaining all you must know, like how to find the conditional mean. I'll show you. I know that this is not a valid probability density function. Still, I'll just show you what is a procedure. So the procedure is, let's say you have a random variable y. How do you find the expected value of y? So it is integration over all y. It is y into its probability density function. So you all are aware of this. It is y into the probability density function of y and then dy. So this is how you find the expected value of y. But what is asked is the expected value of y for a given x equal to 1.5. So let us just write for a particular, let's say small x instead of 1.5. How do you find this? So it is like, it is expectation over all y, okay, integral y into, now you will have something like this. So let's see what is this. So this quantity that you are seeing is the conditional probability density function of y for a given x. So this is what you have to find. So to find this, you need to know the conditional probability density function of y for a given x. How do you find that? So have a look at this expression. Similar question they gave in the sample paper also, and then they just changed certain data and they gave the question in the gate, but it turned out to be invalid PDF and led to the marks to all. So how do you find the conditional probability density function of y for a given x? So it is calculated like this. It is your joint PDF by the marginal probability density function of x. So this is already given. You need to find this. So how do you find this? So a lot of calculations are involved. So I'll show you how to find the marginal. So look at marginal fx of x is, it is the integration which is done over all the values of y, f of x comma y dy. So this is how you find it. So what are the limits of y? So clearly y is ranging from 0 to x. So y is from 0 to x, and the joint PDF is 2xy and then dy. Complete this integration. So you can treat 2x as constant. The integration is with respect to y, so it is y square by 2. So after substituting the limits, so 2's cancel. If you put x square, x into x is x cube. So we got the marginal density function. So once you have that, what you can do is, you can now substitute that here. The numerator is 2xy and the denominator, that is the marginal density function of x, is how much? It is x cube. So this ratio is how much? It is 2y by x square. So now I have this conditional probability density function of y for a given x, which is 2y by x square. What are we supposed to do? We are supposed to substitute this quantity here and then try to find the integral value. So let us substitute that here. The expected value of y for a given x, okay, for a given, let's say, small x, it is, the integration is done over all the values of y. So y is ranging from 0 to x. So it is y into the conditional probability density function of y for a given x, which is 2y by x square. So it is 2y by x square and then dy. You can take 2 by x square out, okay. So while doing this integration, you can treat x as constant. The integration is with respect to y. So 2 by x square is out. What is left is y square. Y square integration is y cube by 3, where the limits of y are from 0 to x. After substituting the limits, let's see what happens. So this is 2 by x square and this is x cube by 3. So after cancellation, it is 2x by 3. So this is your conditional mean of y for a given x. In the question, they asked what is the expected value of y for x equal to 1.5. This was the question. So it is 2 into 1.5 by 3. So the numerator is 3, denominator is 3, hence the ratio is 1. So initially they gave a key like this, but after some days they gave the final key, and in that they have mentioned that marks to all. So what's the reason behind that? The reason is that when you perform this double integration over all the values of x and y, this double integral value should give you 1, but it was not 1. So it's an invalid joint PDF, hence, so this becomes meaningless. That's why marks to all was given. Next, let's look at this question. Two fair coins are tossed independently. X is a random variable that takes a value of 1 if both tosses are heads and 0 otherwise. Y is a random variable that takes a value of 1 if at least one of the tosses is heads and 0 otherwise. The value of covariance of x comma y. Covariance, okay. Computer science students are completely like, they are new to this. So if you are preparing for data science, yes, you need to learn what is covariance, what is correlation and so on. He clearly says that two coins are tossed. When two coins are tossed, what is the sample space? Sample space contains points like tail tail, tail head, head tail and then head head. This is the sample space. He defines about x. X is a random variable that takes a value 1 if both tosses are heads. So x is taking the value called 1. So in which case when both are heads, that's fine. So what's the probability of x equal to 1? The probability of x equal to 1 is clearly 1 by 4, because the probability of head head is 1 by 4. Next, so x is a random variable that takes a value of 1 if both are heads, that's fine, and 0 otherwise. So what are the other points, students? The other points are tail tail, tail head, head tail. In this case, x takes 0, and what is probability of this? The probability of x equal to 0. How many points are there? There are 3. So you can also say head head is only 1 point among 4, so it's 1 by 4, and the remaining 3 are here, so the probability of this is 3 by 4. Okay, so this is about x. So instead of all this information, you can keep it in a simple way like this. Instead of writing all this, what you can do is you can simply write like this: x takes only two values, one is 0, other is 1. And what is the probabilities? The probability of x equal to 0 is 3 by 4 and the probability of x equal to 1 is 1 by 4. So this is the information that we need. It's a very important information, students. Let's keep this aside. This is about x. Next, so what about y? Y is a random variable that takes the value 1 if at least one of the tosses is head. At least one of the tosses is head. So will this be okay? Tail head, head tail, yes, head tail is also fine. and then head is also fine, because at least one toss is head it seems. So in such case y takes the value called 1. What is the probability of this event? Since out of the 4, 3 points are here, the probability of this event is 3 by 4. And what about y equal to 0? Otherwise it is 0, otherwise means at least one of the like he says, at least one of the toss is head. That means in the case of tail y takes 0, and the probability of this event, the probability of y equal to 0 is clearly 1 by 4. Instead of all this, let us keep the things in a simple way. Let us keep the things in a simple way and then just write information about y in this way. Y takes values 0 and 1, and what are their probabilities? You have to be little careful. The probability of y equal to 0 is 1 by 4, the probability of y equal to 1 is 3 by 4. Now this is important. Now they are asking you what's the covariance of x comma y. So what is needed to find the covariance? The covariance of x comma y is, it is expectation of xy minus expectation of x into expectation of y. This is what is needed. So you need the individual average values, and also you need expectation of xy. We will find them one by one. Maybe here I can find expectation of x. How do you find expectation of x? X takes these two values with the respective probabilities. So finding the expectation is simple. It is 0 into its probability, which is 3 by 4, plus 1 into its probability, which is 1 by 4. So how much is this answer? This answer is 1 by 4. Keep this aside. Now it is expectation of y. So this into this plus this into this, which is 0 into 1 by 4 plus 1 into 3 by 4. So obviously this is 3 by 4. So now we got E of x, E of y, we got this, we got this. We are just waiting for expectation of xy. So what could be expectation of xy? So for that, so this is where we can go wrong. So once when I solved this, I was also like, I did a mistake earlier, so I wouldn't, let me just show you how to do this expectation of xy. So what are the possible values of xy? So what are the possible values of xy? For example, xy will take 1 and it can take 0. It can't take any other values, it can take only these two values. When will it take 1? It will take 1 in the case of x equal to 1 and in the case of y equal to 1. Okay. So this is when the product can become 1. Now when will it take 0? It will take 0 in the case where x is 0, y is 0. It will take, xy will be 0 when x is 1 and y is 0. Or in the case of maybe let us reverse this, x equal to 0 and y equal to 1. So here there are only 4 possibilities. 4 possibilities are x equal to 0, y equal to 0 is one possibility, x equal to 1, y equal to 1 is second possibility, and these are the 2 possibilities. So we have got 4 possibilities. So let me explain in a detailed way. Xy will take only 2 values. What are those 2 values? 0 and 1. When will xy take 0? In these cases. When will xy take 1? When x is 1, y also is 1. Now I am interested in their probabilities. So what is the probability of xy? How do you write this? See here, this is x, this is y. Once again I am explaining 0 0, 0 1, 1 0, 1 1. These are the possibilities, students. In this case xy is 1, that means among the 4, in this case the value of xy is 1. So the probability of this event will be 1 by 4, students. And in all the remaining cases, xy is 0. So the probability, since there are 3 such cases or 3 points, the probability of this event is 3 by 4. So I now know the possible values of xy and their probabilities. It's easy to find the expectation. So this was a very interesting observation. I hope you are also following this. What did I say? I said, look, xy take, these are the possible cases. X can be 0, y can be 0, x can be 0, y can be 1, 1 0 or 1 1. In these 4 cases, tell me in how many cases xy, the product is 1. In only one case the product is 1, and in remaining all 3 cases the product is 0. So, since in only one case the product is 1, 1 by 4. Since in all the 3 cases the product is 0, 3 by 4. So, I need expectation of xy. So, how do you find this observation into its probability? 1 into 1 by 4 plus this observation which is 0 into 3 by 4. How much is this? This is 1 by 4. Now, we have got expectation of xy and the individual expectations. Okay, let us keep this aside. Now, you substitute these values to get the final answer. So, what is expectation of xy? Just now we calculated expectation of xy is 1 by 4 minus. What is expectation of x? Expectation of x is 1 by 4 into expectation of y 3 by 4. So, 1 by 4 is common. What is left is 1 minus 3 by 4. 1 minus 3 by 4 is 1 by 4. So, the answer is like 1 by 4 into 1 by 4, which is 1 by 16. You can use your calculator and give a decimal value to this 1 by 16. So, a fantastic question again. This is also fantastic question. So, students, these are the questions from probability and statistics. You can see I have solved more than. So, here I have mentioned that 10 questions are there, but if you see, one was in the aptitude and other was related to other topic where 5 random variables was given. Which question is that? So, this question might also be explained in another subject, but I have solved this many questions, so which account to nearly 20 marks. I hope you will definitely get a benefit from this. After watching this, you will learn some new things. So, I will also solve questions from linear algebra and calculus.